Here's what China's Tianwen-1 spacecraft actually saw when it observed the Interstellar Object 3I Atlas from Mars orbit.
These images were taken between September 30 and October 3, 2025.
What you're seeing here are stacked images captured by the HiRIC camera aboard China's Tianwen-1 spacecraft. At the center of each panel is the bright coma surrounding the nucleus of the Interstellar Object 3I Atlas. The coma is a cloud of dust and gas released as the object becomes active while traveling through the inner solar system. Across the image, you can see many long streaks of light. These are background stars. During the exposure, the spacecraft tracked the motion of 3I Atlas so the object remains centered while the stars appear stretched into trails. In the first panel, two arrows mark important directions. One arrow points towards the sun, while the other indicates the direction of the object's velocity as it moves through space. As we move from left to right across the three observations, the shape of the dust surrounding 3I Atlas appears to change and stretch. This effect is mainly caused by the changing viewing geometry between the spacecraft, Mars, and the interstellar object as the observations progressed over several days.
To reveal the structure of the surrounding dust cloud more clearly, scientists first applied an image processing technique known as a 1/row enhancement. Normally, the brightness of the coma decreases rapidly with distance from the nucleus, which makes faint structures difficult to see. The 1/row processing removes this brightness gradient, allowing subtle dust features to become visible. With this enhancement applied, the structure of the dust surrounding 3I Atlas becomes much clearer, showing how particles spread outward from the nucleus. But scientists didn't stop at the images themselves. They also compared these observations with dust dynamics models to understand how the particles move after leaving the object. The colored curves overlaid on the images represent theoretical paths that dust particles would follow after being released. The solid curves, called syndines, correspond to particles of different sizes affected by solar radiation pressure. The dashed lines, called synchrones, represent dust release at different times before the observation. By comparing the real dust structure with these model curves, researchers can estimate both the size of the particles and when they were released. The alignment of the observed dust cloud with specific syndine lines suggests that the coma of 3I Atlas is dominated by relatively large dust grains, roughly hundreds of micrometers across.
These observations provide a rare view of an interstellar object from a completely different vantage point in our solar system. From its orbit around Mars, China's Tianwen-1 spacecraft was able to observe 3I Atlas in ways that telescopes on Earth could not easily achieve. The analysis suggests that the dust surrounding the object is dominated by relatively large particles, offering clues about the environment where this interstellar visitor may have originally formed. And the story of 3I Atlas isn't over yet. The object continues racing through the solar system at nearly 60 kilometers per second and will make its closest approach to Jupiter on March 16, 2026, passing about 53 million kilometers from the planet. What do you think we might learn next from this interstellar visitor? Because before long, 3I Atlas will leave our solar system and continue its journey through interstellar space.